Hi students, today I will explain some previous iit-jee questions in the concept classification of elements. One, the electronic configuration of atom of element X is n minus 2, n minus 2 S2, n minus 1 S2, n minus 1 P6, n S2, and P5. If n equal to 3, if n equal to 3, n equal to 3 means n minus 2 is 1. So 1 is 2, 1 is 2, n minus 1, 3 minus 1, that is a 2. So 2 is 2 and n minus 1 P6 means 2P6, 2P6. N is 2 means n is a 3, so 3 is 2, 3P5. So the element have a configuration 1 is 2, 2 is 2, 2P6, 3 is 2, 3P5. So the valency shell is a 3 is 2, 3P5. So sum the electrons. S has a 2, P has a 5. Total electrons are 7. So the element is belongs to 17th group or 7th A group. And period is the n value is 3. So the element is a third period element. Okay, either 17th or 7th A group, and a period is a third period. Okay, and see the next one. Atomic radii of fluorine and neon in angstrom units, in angstrom units or respectively. See here, what is a atomic radii? Atomic radii, here the distance between a nucleus and valency shell is known as an atomic radii. Individually, atoms are not existed. That means atom is present always in combined state, not in an atomic state. So, on the basis of the nature of the bond formation, atomic radii is differentiated. That means either if a molecule involved in a atom is involved in a covalent bond or ionic bond or metallic bond, or it is in a van der Waals force, like that. See, the generally in periodic table the atomic radii is in groups. Generally we will say the atomic radii in groups top to bottom increases. Top to bottom increases. Groups top to bottom increases. And in a period it is decreases. Left to right period decreases. But in period we don't observe a regular trend. Okay, in a periodic table the radii decreases, but a last group is a eighth A group. Those are stable elements. So comparing to a below group, that is a seventh A group, seventh and eighth A group elements, seventh A group elements are smaller than eighth A group elements. Due to stability, they have a larger size than comparing to seventh A group. See, the fluorine is a seventh A group element. Neon, next element of a fluorine, that is eighth A group element. Okay, so the radii of 7th A group elements is less than a radii of 8th A group elements. Fluorine has a small size than comparing to neon. Okay, we don't know values, but according to the periodic properties in periodic table, how the atomic radii varies, we will set the values. That is a 0.72 and 1.60. These are the radius of a fluorine and neon. See the next one. The correct order of radii. See here. some neutral atoms are there and some ions are there, positive ions and negative ions are there. See the radii in a normal and a positive charge carrying one, negative charge carrying. That means how the radii vary in a neutral atom, cation and anion. Suppose take a example oxygen. Oxygen is in a neutral state and carrying positive, carrying negative. See, oxygen in neutral state, it has a protons. Atomic number is a 8. So it has a protons 8 and electrons are 8. Okay. And next O plus means it has a protons are 8 but electrons are atomic number minus charge. So 8 minus 1, 7. 8 minus 1, 7. And here oxygen O minus. Here also protons number is a constant. But electrons are a atomic number charge minus. So add a plus 1. So electrons are 9. In all the three cases, the proton number is the same. That means nuclear charge is the same. But the electrons are varying. So due to the varying the electrons, what happened? Nuclear charge here oxygen to O plus nuclear charge increases. Why? The surrounding electrons are decreases. And oxygen and O minus, their number of electrons increases. So due to increasing electrons, nuclear charge decreases. So the increasing charge here in oxygen and O plus, what happens? Nuclear charge increases. So due to the nuclear charge increasing, attraction between nucleus and valency electrons increases. So due to that, what happens? The size is decreases. That means oxygen has a greater size than O plus. O plus. In O minus and O, here the nuclear charge decreases. So due to decreasing charge, O minus has a larger size than O. So what is the order of a radii of these three is O minus is greater than O is greater than O plus. This is a decreasing order of a size. Decreasing order of a size. Bigger to smaller. Increasing order is a O plus is less than O is less than O minus. That means the neutral atom have a medium size. That means a cation have a small size. Then comparing to neutral. Neutral has a small size. Then comparing to anion. Okay. If you take any atom, it is existed in a three states: cation, neutral, anion. Cation has a low size and neutral. After that, neutral. After that, anion. Anion has a bigger size. Okay. If and one more another case, that is if a positive charge increases, the nuclear charge also increases, size decreases, radii decreases. So take up cations Na plus Mg plus 2 Al plus 3. Here the three atoms have same number of electrons but the nuclear charge, protons number 11 here proton number 12, here proton number 13. So in these three, nuclear charge increases but the electrons are 10, 11 minus 1, 10 and electrons 11 minus 2, 10. Here also electrons 13 minus 3, that is 10. In all the three cases, the number of electrons are same but the nuclear charge increases. So if a positive charge increases, what happens? Nuclear charge increases. If nuclear charge increases, size decreases. So Na plus is greater than, Mg plus 2 is greater than Al plus 3. Okay. From these, what we understand? If a cation, the charge increases. Okay. In cations, charge increases, size decreases, radii decreases. And take the anions. Take the anions. O minus and O minus 2. See only these two. Oxygen here also has a 8 protons. Here also has a 8 protons. But electrons are here 8 plus 1 9. Here the electrons are 8 plus 2 10. So the electrons increases. Number of electrons increases. The nuclear charge decreases. If the nuclear charge decreases, size increases. So what happened? O minus is less than O minus 2. The radii of O minus is less than O minus 2. Okay. From this, what we understand here in anions, size charge increases, size also increases. In cations, charge increases, size decreases, and in anions, charge increases, size also increases. Size also increases. See the options here. Nitrogen is less than, beryllium is less than boron. Okay. And F minus is less than O, 2 minus is less than N minus 3. Here we will see on the basis of a charge. If a same atoms or different atoms, they carry negative charge, and here the negative charge is in an increasing order. If a negative charge increases, size increases, atomic radii increases. Here, see, iron. Okay, plus 3, plus 2, plus 4. Plus 4 has a less sign. If you write like this, Fe plus 4, Fe plus 3, Fe plus 2. Because the positive charge increases, size decreases. And sodium, lithium, potassium. There are group elements. Lithium is less than, sodium is less than potassium. Okay, this is the second period, third period, fourth period elements. Okay, in a top to bottom, size increases. So potassium has a larger size than a sodium. Sodium has larger size than a lithium. But here it is in a different order. So this one mistake wrong. This is also wrong. But it is according to the charge. According to the charge. F minus is less than O. 2 minus is less than N minus 3. Okay. You need to take a protons and electrons. Only you will take the charge. And next, the cell represent the correct order of first IP. What is the IP? Ionization potential. The minimum amount of energy needed to remove the electron from the valency shell of an atom. It is in a isolated and gaseous state. Okay, that energy is known as a ionization potential. Simply, the energy needed to remove the outer electron, is known as a ionization potential or ionization energy. In groups, top to bottom IP decreases. Top to bottom IP decreases. In period, left to right, IP is increases. Okay, sometimes increases, sometimes it will decreases. On the basis of the electronic configuration, it does not show a regular trend in a period. But generally, it increases. In groups, IP decreases. In period, IP increases. Here, decreasing order is given. See the group elements. See, potassium, sodium and lithium. This is a order from bottom to top. Top to bottom decreases, bottom to top increases. But here he give a decreasing order. Okay, lithium has a highest IP, but here he give a lowest IP. And see the second one. Beryllium, magnesium, calcium. These are the second A group elements. Beryllium, magnesium, calcium. Top to bottom decreases. So beryllium has a more IP. Calcium has a less IP. So this is a correct one. And boron, carbon, nitrogen. These are period elements. Period left to right increases. That means the correct order is a boron is less than, carbon is less than nitrogen. But here he given a reverse order. So it is also a mistake. And germanium, silicon and carbon. These are also fourth A group elements. Carbon, silicon, germanium. So top to bottom decreases means germanium has less IP and carbon has a more IP. So this is also wrong pattern. Here only give up beryllium is greater than magnesium is greater than calcium. These are correct pattern, correct arrangement of a IP.